Dear students, today let us discuss another distribution, which is the normal distribution. It is again from module 3 of your complex analysis, probability and statistical methods. So in the same module we have already learnt about binomial distribution, Poisson distribution, exponential distribution, and the next one which we are going to learn today is normal distribution. So what is normal distribution is? So however, in the binomial distribution, Poisson and exponential, first we have to define what is it and how the function looks like, and then we also discuss probability density function with respect to particular probability distribution, and then we will be proving it, and then we will be moving on to the problems. Here also let us follow the same way of approach. So what is normal distribution is? So if f of x, let us consider f of x, which is equal to 1 divided by sigma into square root of 2 pi, it is multiplied to e to the power of minus of x minus mu whole square divided by 2 sigma square. So where x takes the values between minus infinity and plus infinity, mu takes the values between minus infinity and plus infinity, the value of sigma should be positive, that is greater than 0. And only when these conditions are satisfied, we can call f of x as a normal distribution. So remember, x and mu takes the values from positive infinity to negative infinity to positive infinity, and sigma value should always be a positive one, that is sigma greater than 0. So in order to prove that, as I said, the procedure, first we'll define and then we will show it as a probability density function. So here too we will do that, show that this function whatever we have defined is a probability density function. In order to do that, consider your definition of normal distribution, which is f of x is 1 divided by sigma into root 2 pi e to the power of minus x minus mu whole square by 2 sigma square, and the condition along with sigma should be a positive value. So sigmas, when this case f of x should be a positive value, and in order to prove the probability density function, and this normal distribution happens to be a continuous probability distribution, so we have to consider the integration between minus infinity to infinity f of x dx, and we have to prove this minus infinity to infinity f of x dx integrand gives us the value as 1. So let us substitute for f of x as 1 divided by sigma square root of 2 pi e to the power of minus x minus mu whole square by 2 sigma square between the limits minus infinity and infinity. So in order to integrate that, we have to go for substitution method. Straight away it looks little complicated, so we are going to use substitution method for integrating the normal distribution function which we have defined in the previous slide. So what is the substitution that we will take here is, take the exponential power, whatever is there in the exponential power, that I'll take, let t is equal to x minus mu divided by sigma into root 2. Substitute this as t, and x is equal to, on simplifying this, x will be equal to mu plus sigma into root 2 into t. And since we are converting everything in terms of x, and we need to find dx here, which is on differentiation with respect to x, sigma into root 2 and differentiation of t becomes dt, and mu becomes 0 as it is a constant, and t varies here from minus infinity to infinity. So we all know that whenever we perform integration and if we make any substitution in the integrand, you have to check for the limits with respect to the new substitution whatever we have made. On checking that, we get the value for t, the limits for t as minus infinity to plus infinity, which remains same as t and x. So now consider your integrand minus infinity to infinity f of x dx, and 1 divided by sigma into root 2 pi as a constant, you can write it outside, and integration is applicable only for e to the power of minus t square sigma root 2 into dt. You have substituted for dx as well as x. So on simplifying this, we get 1 divided by root pi minus infinity to infinity e power minus t square dt. And minus infinity to infinity integrand, integration of minus infinity to infinity can be written as 2 times of 0 to infinity, and integrand remains the same, that is e to the power of minus t square dt. And integrating this And in gamma functions, you might have remembered, an integration of this 0 to infinity e power minus t square dt gets the value root pi by 2. So 1 by root pi, which is there outside, and 2 is, we have taken it out. And integration of 0 to infinity e power minus t square dt is root pi by 2. So on cancelling everything, we get minus infinity to infinity f of x dx is equal to 1. So this is how we need to prove that the normal distribution function f of x is a probability density function. So once after proving it as a probability density function, the next step is that we have to check what is the mean, standard deviation and variance with respect to the normal distribution. So what is the mean here? The mean for the normal distribution is mu, the variance is sigma square, and standard deviation is sigma. Standard normal variate. Usually we used to take the Poisson variate, binomial variate like that. Now for a normal distribution it is a normal variate. This normal variate looks like, the values of normal variate looks like the bell shaped curve. It starts from almost equal to minus infinity and reaches the peak, and then it will come back to the plus infinity. And however it is, the sum of the integration of the whole normal variate should be equal to 1. That is what has been explained here in this graph. So in case of normal distribution, in case of normal distribution, it is the lower limit and upper limit is not exactly minus infinity and infinity, and instead we will take the values a and b, some finite values. So p of a less than or equal to x less than or equal to b. It means that x varies from a to b, and distribution varies. Since it is a variate, p of a is less than or equal to x less than or equal to b is being written here. And on the other side, it is a definition of normal distribution. So here let us substitute z is equal to x minus mu by sigma. So which gives us x is equal to mu plus sigma into z, and dx is equal to sigma into dz. So what we are trying to do here is, the first part what you have proved is for an infinite limits, and every time we will not be getting infinite limits. So we will have some finite limits also. In such case, how to proceed? That is what has been explained in this particular slide. So a and b are the finite values. So whenever we want to calculate with respect to a and b, the procedure which we have adopted here is this. We have made a substitution for z, and we are converting everything in terms of x and dx, and substitute the limits for x, upper limit and lower limit. The lower limit is a. So when x is equal to a, z gives us a minus mu by sigma, and when x is equal to b, it gives b minus mu divided by sigma. Since z has been assigned upper limit and lower limit, just to have a differentiation between them, we'll take them as z1 and z2. z1 be the lower limit and z2 be the upper limit. And p of a less than or equal to x less than or equal to b, and on substituting for x in terms of z, we get integral minus z1 to z2 e to the power of minus z square by 2 sigma into dz. So here p of a less than or equal to x less than or equal to b is being converted to p of z1 less than or equal to z less than or equal to z2. The variate x has been changed to z, and a and b have been changed to z1 and z2. That I have explained in the previous slide. 1 by root 2 pi z1 to z2 e to the power of minus z square by 2 dz. So on substituting for z, x minus mu by sigma, which is a standard normal variate. So before going to the problem, there are few things that you need to remember here. P of minus infinity, that minus infinity less than or equal to z less than or equal to infinity. So z is the normal variate, and if it varies between minus infinity and infinity, the probability of that is equal to 1. The probability density function, that is. And at the same time, p of minus z1 less than or equal to z less than or equal to z1 can be written as 2 times of p of 0 to z. Z varies between 0 to 2. Actually, it is p of z varying between minus z1 to z1 plus z1 can be written as 2 times of 0 to z. So in other words, you can write it as 2 into phi of z. P of integral 0 to z can be written as phi of z1. And another, there is another one, the second one, p of minus infinity less than or equal to z less than or equal to 0. R, p of z less than or equal to 0. This value, the probability of this value is half, because you are considering only the minus infinity to 0 part. So it is exactly half of your minus infinity to infinity. So that is why it gives the value as 1 by 2. Similarly, if you take the other side, minus infinity to plus infinity, I'll show you this. So for example, if you take this straight line and in between you have 0 and here you have minus infinity and here you have plus infinity. Okay, so here minus infinity to 0 is half. Similarly, 0 to infinity, the probability also to be is equal to half. That is what is the meaning here. So moving on to the next, p of minus infinity to z1. Similarly, p of minus infinity to 0, p of minus infinity to z1 can be written as minus infinity to 0 plus 0 to z1. So that I'll explain you here. Take a straight line. Here you have your minus infinity and you have here 0 and here you have z1. It is not exactly equal to plus infinity, so minus. So p of minus infinity to z1 can be written as minus infinity to 0 plus 0 to z1. That is what is the fourth expression tells you, which implies p of z less than z1 can be written as p of z less than or equal to 0 plus p of z less than z1. So we know that p of z less than or equal to 0 is nothing but half. In the second expression we have discussed that. Plus p of 0 to z1 can be written as p of z less than z1. So which has been taken as phi of z1. Next, coming to the next, p of minus z1 less than or equal to z less than or equal to minus z2 is equal to p of z2 less than or equal to z less than or equal to z1. So which can be written as p of z greater than z2 can be written as p of z greater than or equal to 0 minus p of z less than z2. So p of z greater than or equal to 0 is nothing but 0.5, that is half, minus p of z less than z2 can be written as p of phi of z2. So these are the few things which you have to remember before getting into the problem. So this is your normal distribution table, and this normal distribution table is usually used while working out the problems. So your mu value has been taken in the horizontal direction and your z value has been taken in the up to down, that is vertical direction, downward at vertical direction. So I'll be exactly explaining you how to use this table during the problems. So let us consider the first example. Evaluate the following. First one, it has been asked us to evaluate P of Z greater than or equal to 0.85. Second one is P of Z less than or equal to minus 2.43. And the third one is P of minus 1.64 less than or equal to Z less than or equal to minus 0.88. There are three cases which we need to evaluate it here. So consider the first one. For what is this first one is P of Z greater than or equal to 0.85. So whenever we get greater than or equal to, it is always good to take in the form of P of Z greater than or equal to 0 minus P of Z less than or equal to 0.85. Because is that greater than or equal to 0.85 can be anything, it can go up to infinity also. So in order to avoid that, we can use this P of Z greater than or equal to 0 minus P of z greater than 0 itself is, it can go up to infinity. In that, we are subtracting the value which is z less than or equal to 0.85. And we know that P of z greater than or equal to 0 is half. In the note I had specified there. And P of z less than or equal to 0.85 can be written as phi of 0.85. What is this phi of 0.85 is? So this phi of 0.85, you need to get it from your normal distribution table. That I'll be explaining you. Here the value of z is, the value of x here has been taken as 0.85. So let us go to your normal distribution table. So 0.8, you have to take it in the vertically downward direction. So where is it? Point 0.8 is here. You can observe point 0.8 is here. And you have to go till 0.05 because that is in the third decimal place. So the value was zero point 0.8. Look at the lines exactly. 0.8 at 0.05, which is 3023. So let us check. Let us go back and let us go to the next slide where we had a problem. We were solving the problem here. So phi of 0.85. So phi of 0.85 is 0.3023, which we have taken it from our normal distribution table. So on subtracting zero point 0.5 minus 0.3023, we get 0.1977. So hope you understood how to evaluate this point phi of 0.85. Similarly, let us move on to the second subequation. The second subequation here is the z value varies between minus 1.64 to minus 0.88. So by in the note again, you can go back to the note and check where we have minus that one and upper limit and minus lower limit. When both are having negative sign, we can write that in the reverse way. Upper limit becomes the lower limit and lower limit becomes the upper limit, so that we can avoid that negative sign. So P of minus 1.64 less than or equal to Z less than or equal to 0.88 can be written as P of 0.88 less than or equal to Z less than or equal to 1.64. So this, which we can write it as P of 0 less than or equal to Z less than or equal to 1.64. Take the upper limit 0 to 1.64. In that, we are going to subtract the lower limit P of 0 to 0.88. So you understood, dear students. So here upper limit is 0.164 and lower limit is 0.88. So whenever we perform the integration, it is always upper limit minus the lower limit. So probability function also will do it in the same way. So upper limit first, probability of 0 less than or equal to Z less than or equal to 1.64 minus the lower limit is P of 0 less than or equal to Z less than or equal to 0.88. So P of 0 less than or equal to Z less than or equal to 1.64 can be written as phi of 1.64 and minus 0 to 0.88 can be written as phi of 0.88. So phi of 1.64, you have to get it from the normal distribution table, and phi of 0.88 you have to get it from your normal distribution again. So let us go back to our normal distribution. So it gives us, so look at this 1.64. You can in the vertical direction, if you come down 1.6, so here you have 1.6 and at 1.6 you have to move till 0.04 because 1.64 the value here is looks for 0.44 something, so 0.4495. That value we're going to enter here in this 0.4495. Similarly, 0.88, phi of 0.88, you have to take 0.8 in the vertically downward direction. Again, move horizontally till you get 0.08, and which gives the value as 0.3106. So on subtracting or performing the evaluation, we get 0.1389. So this is with respect to the second subequation. And the third subequation here was P of Z less than or equal to minus 2.43. So we can write it as Z greater than or equal to 2.43. It is just to avoid our negative sign so that we can perform the problems in a better way. So which we can write it as P of Z greater than or equal to 0 minus P of Z less than or equal to 2.43. The same technique which we have used in the first equation, we are using it here. P of Z greater than or equal to 3 is 0.5. That is a standard value which we know. And P of Z less than or equal to 2.3 can be written as phi of 2.43. So which we have to get it from the normal distribution table. We have to move vertically downward till you get 2.4. At 2.4, move horizontally till 0.03. And on doing this, you get 0.4925. On subtracting the 0.5, subtracting 0.4925 from 0.5 gets 0.0075. This is with respect to the third sub question which has been asked us to evaluate in the example 1. So similarly, let us solve another example, which is example 2. If x is normally distributed with a mean 12 and standard deviation as 4, we need to find p of x greater than or equal to 20 and p of x less than or equal to 20. So here mean has been given and standard variation has been given, and we need to find p of x greater than or equal to 20 and p of x less than or equal to 20. So given mu is to 12, mu is nothing but the mean, and standard deviation is sigma is equal to 4, and x here is 20, normal variate x here is 20. So normal variate expression is that is equal to x minus mu by sigma, and substituting for x 20 and mu as well as for sigma, we get z is equal to 2. So we had obtained the value of z. And first question, consider the first one. Your normal variate starts from 2. That is what the meaning here is. P of x greater than or equal to 20, which can be written as P of z greater than 2. So when x is greater than or equal to 20, on evaluating we had got z is equal to 2. So z greater than or equal to 2 to be evaluated here. So whenever we get greater than, it is always better to go for the standard expression, which is P of z greater than or equal to 0 minus P of z less than or equal to 2. So P of z greater than or equal to 0, in the note it has been specified, it is 0.5, and less than or equal to 2, P of less than or equal z less than or equal to 2 can be written as phi of 0.2. Phi of 2. So phi of 2, again you have to obtain from your normal distribution table, which is 0.4772, and subtracting this value from 0.5, you get 0.0228. And the second case which it was asked us to evaluate is P of x less than or equal to 20. So when x is 20, we have evaluated the value of z happens to be 2. So z less than or equal to 2. On converting x to z, z is less than or equal to 2. So less than or equal to 2, P of z less than or equal to 0 plus P of z less than or equal to 2. So here P of z less than or equal to 0, from the note again 0.5, and P of z less than or equal to 2 is nothing but phi of 2. So phi of 2 should be obtained from the normal distribution table again. So 0.5 plus 0.772, and our answer is going to be 0.9772. So let us see another example for better understanding. In a normally distributed, 31% items are under 45 and 8% of the items are over 64. Find the mean and standard deviation of the distribution. So normally distributed data has been taken. 30% of the items are under 45 and 8% of the items are over 64. Okay, under and over. Try to understand, try to remember these words properly. So given that P of x less than or equal, less than 45. So go back to your question. 31% of the items are under 45. Under here is specifying less than, and over 64, that is more than 64. So P of x less than or equal to less than 45 is 31%, which has been given for us, and on converting it to decimal points it is the 0.31, and P of x over 64 is 8%, that is 0.08. This is the data given for us. At x is equal to 45, we need to evaluate the normal variate z. So z is 45 minus mu by sigma, which is equal to z1. So we doesn't know the value of mu and we doesn't know the value of sigma. So let us take that as our lower limit, which is z1. At x is equal to 64, z becomes 64 minus mu by sigma, and let us take this as z2. Call them as equation 1 and 2. P of z less than z1. So consider your first expression z less than z1, which has been given as 0.31. P of x less than 45 has been converted to P of z less than z1, which is 0.31, which can be written as P of z greater less than 0 plus P of z1 less than or equal to 0, which can be written as 0.5 plus phi of z1, which is equal to 0.31. Similarly, equation 2 can be written as P of z greater than 2 greater than z2, and it has been given as a percentage of 0.08. And p of z greater than z2 can be written as p of z greater than 0 minus p of z greater than z2. So zero point 0.5 minus 0 pi of z2. So, on solving these two equations, zero point 0.5 plus phi of z1 is equal to 0.31 and zero point 0.5 minus phi of z2 is equal to 0.08. Solving these equations, we get phi of z1 is equal to minus 0.19 and phi of z2 is equal to 0.42. So phi of Z1 and Z2 we have evaluated. 0.42 is approximately equal to 0.4192, which is the value of phi of, you have to do the reverse engineering now. So you have go back to your normal distribution, identify your 0.4192 in the table. So take the value horizontally and vertically. So the horizontal one you should write first, that is 1.4, and vertical one is 0 I feel, so it is 1.1. This is, so 0.4192 is phi of 1.4. So z1 is equal to minus zero point 0.5 and z2 is equal to 1.4. So equation 1, let us substitute these values in our equation 1. So minus zero point 0.5 is equal to 45 minus mu by sigma. So mu is equal to, on solving this we get mu is equal, rewriting the expression, mu minus zero point 0.5 sigma is equal to 45. Similarly, equation 2 gives us 1.4 is equal to 64 minus sigma by 6, say mu by sigma. Rewriting this as mu plus 1.4 sigma is equal to 64. So solve the equation simultaneously. We get the value of mu as 50 and standard deviation as 10. So this is how we need to work out the problems. And all the three examples what we have solved are of different type. So similar problems have been solved in the notes. Try to go through the notes and understand the concept in a better way. So thank you.